Hey guys, this is Stats Day 4. So today we're going to be focusing mainly on normal curves. So if you remember from yesterday, normal curves are, they're symmetric on both sides. So the left side is exactly the same as the right side. So this middle line right here, okay, this is going to be your mean. And then each line that we go to the right means that it's one standard deviation above. And if I go to the left, it's one standard deviation below each time. So it'd be one below here, two below here, three below here. So the point of a normal curve is that it tells us about the percentages of a situation. Okay, so if I have a situation where we're talking about, let's say, test scores. Okay, so if I'm talking about test scores, I want to know the average, and then I need to know the standard deviation to create my normal curve. So let's say that this was a really great test, everybody did really well on it, and let's say that the average was an 87. Okay, so I put the 87 in the middle here. That's my mean, that's my average. Okay, and then the standard deviation is, let's say, 2. Okay, so my mean is 87. And then my standard deviation is 2, so I go up 2 each time. So this would be 89, and then I go up 2 again from there, and then I have 91, and then 93. Okay, so that's one standard deviation above each time, and then I go one standard deviation lower each time. So if it's 2, I'm subtracting 2 each time. So I'm doing 87 minus 2 would be 85, and then I just keep subtracting 2 each time. Okay, so what this tells me is I can have a, if I want to figure out how many people got above an 87. 87 is right in the middle. So since this is split equally in half, what that means is 50% is on the right and 50% is on the left. So if I want to know how many people scored above an 87, I can say, okay, 50% of the class did better than an 87. So for your normal curve, there are specific percentages between each standard deviation. So between one standard deviation, so these numbers in here are changing depending on the situation that they give you. So the middle is always your mean, and then you go up a standard deviation each time and then down to go to the left. But these numbers that I'm giving you right now, these percentages, those are always going to stay the same. So this is 68% right here. Between one standard deviation, between two standard deviations is going to be 95%. And then between 81 and 93, these last ones, that's 99.7%. Okay, so if I ask you something like how many or what percentage of people scored between an 81 and a 93, that would be 99.7%. If I asked you how many people scored between an 85 and an 89, you would say 68%. So these are really easy to figure out. We just need to know those numbers. The harder part comes when I ask something like how many people scored between an 81 and an 85, or how many people between an 83 and a 91. So the way that we can figure that out is, like I said, this line right here splits this perfectly in half. So if I know from here to here is 68, I can figure out that each one of these has to be 34% because it's equally split in half. Okay, so then from there, I can figure out all my other percentages by just calculating them. Okay, so in order to do that, I can just take 95 is between this and this. So I can split that in half, but then I would find this whole piece. So something that's a little easier there is I want just this piece right here between these two and this one right here between those two. So I don't want this 68%. So what I can do is 95 subtract 68, I get 27. So the 27 has to be split equally between these two pieces. So I'm going to divide that by 2. And I get that this piece is 13.5%. And this piece is also 13.5%. So if I want to figure out how many people scored between an 83 and an 87, I would just add these two together. So I would do 13.5 plus 34. And I would get 47.5 people scored this high. Okay, so then You can figure it out for the rest of these as well. You're just figuring out these percentages. Then once I ask you something like, okay, who scored between an 81 and an 89? Here are the two lines I'm looking at. I just add up everything in between here. So you just need to find these other pieces, again, by just saying, I'm gonna take 99.7, I subtract 95 because I don't want that bit, and then I'm dividing it into those two equal pieces. Okay, and then over on the edge here, remember all of the data has to be in here, so that has to be 100%. So the last, anything else that's left over is going to be 100%. Okay, so that is for our normal curve. Okay, so that's one way we can find it. So now we're going to talk about z-score. So z-score, what z-score finds for us is it tells us where that number falls on here. So obviously we have our curve here, but if I just told you the mean, the standard deviation, all of that, you can just use the formula to calculate it. So if I want to figure out if someone scored an 82, where would they be? They would be halfway between here. So remember, each of these is one standard deviation. So if I'm in between here, my z-score would be something like negative, because I'm to the left, 1, 2, and it's between 2 and 3. So it'd be between -2 and -3 would be your z-score. So z-score just tells you where do you fall in here. Anything negative is going to be to the left, anything positive is going to be to the right, and each line represents a whole number. So this would be +1 would be your z-score, this would be +2, this would be +3. And anything that has like a decimal, anything that would be like, let's say 0.7, that's positive, and I'm between 0 and 1, so I'd be like somewhere in here. Okay, so to find your z-score, there's a formula for it. It's just z equals the data value minus the mean, and then divided by the standard deviation. Okay, so let's do 82. Let's say that someone scored an 82 and they want to see where they fell. So we do z equals, my data value is the value that you get, so the person that got an 82, minus the mean, and the mean is the 87 because that's what's in the middle, and then divide by the standard deviation. And remember, the standard deviation is just what's the difference between each of these, so it's 2. And standard deviation is always going to be positive here. So then I'm just subtracting 82 minus 87. I get -5, and you have to make sure you have it in the right order, because remember that negative is important. It tells us it's to the left. So -5 divided by 2, and I get -2.5. Okay, so that tells me that my z-score is here. So if you're interpreting this, what that -2.5 means is that person scored pretty low compared to the average. Okay, if someone got 100, that would be a z-score of more than 3. So that would mean that that person scored very high. And obviously this makes sense with looking at test scores and how you did comparing to the median, but we can use this for any type of number that we want. We could say that the heights of someone are normally distributed, or the shoe size, or the number of times that you visit the grocery store, right? So you can use a normal curve for any situation that looks like this, where the data is the highest in the middle and it's perfectly symmetrical on both sides. So this is only specifically for normal curves. That is the only time that you can use this, because normal curves are super special, and they have to fit these certain criteria, that everything is perfectly symmetrical and the median and the mean is right in the middle. Okay, so again, to find any like percentages here, mean always goes in the middle, then you go up a standard deviation each time and down on the left side. To find between two numbers, you're just adding up everything in between here. Okay, then for a z-score, you're just using this formula where you're putting your data value minus the mean and then divided by the standard deviation, and you're going to get some type of decimal. To interpret it, you can just say negative is to the left, positive is to the right, so it's either higher or lower. And then the closer this is to 0, the closer you are to the mean, because 0 would be the mean exactly. Okay, so go ahead and try your homework for Stats Day 4. So that's actually it for this week. There is no Day 5, so make sure you finish up your homework for this week and then submit it through Edsby.